Okay, welcome back everyone. We're going to do character state machines today. So this makes it very versatile. We can do it for the NPCs and the player, and we can give it a separate state for idle, run, dash, jump, and it's great because the code is just isolated into each class, and you can change things within there, and it's easy to debug, and it separates the logic from each other. So it's a big part of what makes this a very scalable system. And it doesn't have to be a top-down RPG style game. It could be a platformer and any other character-based game this will work with. So let's make a start. Where shall we start? So we don't need the camera for now. Let's go into our characters. Did our collisions last time. We can minimize these for now. And our physics. Animate. Images. We've got all our variables here. So how can we separate this into different states? So firstly, I'm going to do the direction. We're going to return a direction depending on the angle the player is moving at, and then the animations will change. So if we look in here in my assets, characters, player, then we've got attack down, attack left, attack right, and they're the different images for that animation. So attack will be the state that it's in, and then we can just append a relevant direction as part of the string, depending on the direction the player is moving. So that's the plan. So let's tackle that one first. So let's put it below images, animate. Just before collisions, let's get the direction. So first we want an angle. So we're going to take the player's current velocity, which is a vector. We're going to use the angle to function, and we just put in here an angle to another vector. So the other vector will be just a simple vector pointing down. So remember, this is x and y. Then from that we want to return the angle from 360 degrees. So we do that by doing this. It's the modulo the 360. And then let's print this. Let's return angle from that, and then we can print this function. So remember, we had a nice debugger in our class. We can put that in here. So angle. Remember, in here we have to call the player self.player get direction, and then that should give us an angle if we run the game. Okay, there we go. So that's 0 down, turn left is 90, up is 180, and left is 270. As there's an acceleration function, it just takes a little bit of time to get to the exact angle, but we've got a nice 360 degrees now that we can use to determine which way our player is moving and therefore which animation. So let's go back to our character. So now we need to output the string of right, left, up or down, depending on the angle of the player. So you can play around with this and see what happens, but this one worked for me. Obviously, it does depend on this vector you put in here. Just want to return right if that happens. So it's returning up for me, and I think it was left. It just means an easy way of putting that the angle is more than 225 and less than more than or equal to 225 or less than 315 here. So left, and then otherwise we just want to return down, and we've got all four directions. And now if we run it, we've still got this function that should give us a string. So let's run our game. So angle is right. If I go down, go up, yeah, right, down, left, up. There we go. As long as I hold up, down, right, and left, it takes a little bit of time to meet the exact angle when we're going at a diagonal, but eventually it kind of catches up. In some directions, it will move to that left or right instead of up or down. I like that. It feels quite natural as it will switch left and right as you move. Obviously, it's not calling the correct animations yet, but we can do that now we've got this string from this function. So that will do for that. We're still in the NPC class, remember? So all our characters, I want to have this. That's why I'm putting it here and not just in the player class. We want movement because even NPCs, when we do cutscenes and things, we want to call a variable that will move our NPC. So we will put a dictionary of left, right, up, or down in here. So we'll call that self.move. Left. By default, these are all going to be false. That's our move dictionary, and then here. So, as you hopefully know already, to call that key in the value of the dictionary, we just call the dictionary and put the key in square brackets, and that will give us the value. So if self move left. So if that's happening, we want the acceleration variable now, which is a vector. So the acceleration x is going to be equal to minus our force, minus self.force. And if moving right, it's positive force. If neither of those, equals 0. We can do the same for up and down. So I'm just going to copy that down. Acceleration y. Remember, down is positive and up is negative. Make sure you get the relevant axis there. So that's our movement, and that should just add that acceleration. Apply the force, because it's physics based, remember, and it will give the acceleration up to the maximum speed. And then in the player, this is going to be slightly different. So hopefully now with the NPCs in a cutscenes, basically the way I do them, I just start them off and a timer starts running, and then I'll just call the variables for the instances and characters in there to what they do. So you can literally just call this NPC move left, and it will do this, and we make that equal true. So if self move left here just means if self move left is true. Obviously by default they're false. So we can just put self move left equals true. And hopefully the NPC will just start moving left, for example. So we can hard code that in when we need it to happen. But our player needs to move via input. So we don't want to inherit this. We will we already did it, of course. We've been moving. So as you can see, I called this the same. So therefore, the player will inherit from NPC, but because we put another method in called movement, it will overwrite this one. If we took this out, it would take this by default. But if you name it the same, it will apply this to that. So this will apply to the player. If input's left, so if we're pressing the left key, acceleration is equal to the force. Okay. So get direction. So now, how can I do this? Just to show as an example. So idle right is default. So if we say idle, so if we use an F string, we can put the different data type in there. So instead of idle right, we want the direction. So it would be self.direction. Self.get direction, I think I called the function. Call that function within here. And that should output the string. So here we should output this string. So that should be idle underscore that. And that should, as it's an update function, always animate with the correct direction. So let's go with that. No, that's not working. Because I did it in class. We just need to put that into the player class. So here. Oh yeah, we did idle and run here. So really we just need to pop this in here instead. We can do the same for run, just to show it for now. And that should work. Yep, there we go. Pressing down, moving to the right, move up and left, down and left, up, directly down, directly left, and directly right. So I quite like that. Everything we need there. Yeah, let's quit play. Continue loading. So let's go on to the states. We're going to make the state machine now. So this is where it gets fun, well, in my opinion. So all we want to do here is we always want this direction to happen. So we're going to put self.get direction in here. And we're going to run the physics. I'm going to take animate out for now. The player is going to inherit the same update function as the NPC. So what I want to do in here is to update the state. So the physics I'm going to put in the state itself. So let's leave that out for now, the animate and the physics. And then we're going to get. I'll show you first how I would build the state. So I'm going to put them at the bottom here. You can easily scale this out. So if I press Control N in Sublime Text, I'll get a new file. And you could easily go from characters, import NPC, go into your characters. You can, for example, import your player here. I've not saved it as a Python file, so it's not highlighting the syntax. And then you could start building your states under here like this. So for different players, enemies, characters, you can put them in separate files like this. But we're not going to do that for this. We're just going to use an. So in characters, we're going to put it under here because the same idle and run state is going to be used for the player and the NPCs. And we can just build on that. So class idle. And then we're going to put functions in there. So we want one function which will be our enter state logic. Character, we're going to pass the character through, which will be itself. So pass for now. And I want to update, which will be self dt, and we're going to pass the character in. Pass for now. And then we can run. So we'll do these two for now. So, and because these are classes, we need to give the NPC an initial class. So let's call it. Let's put it at the bottom here. Excuse me. Self.state, which would be, to begin with, idle. So since we're calling the idle class here, it will pick it up because it's in the same file down here. So with that state, we want to run these classes instead of the ones specifically for the NPC. So if we run those in some form inside this class. So how we're going to do that? Let's close these down. We've got our update function. We just need one more function in here called change state. I'm going to call it self. And in this function, self.state enter state self. So that's going to run that within the class, within the state, sorry. Or rather, that's going to make the new state equal to that. If there's a new state, self.state current state is equal to that new state. Otherwise, self.state is just that. So that would be all we need, and then we can just call that in here. Change state. Seeing as we're in the idle state to begin with, let's see if we can add our course. So we're going to put our physics into here. Sometimes we might not want the physics, we might just want the player to stand dead still, in which case we can leave this blank and it will do nothing. So that's the good thing about these state machines. It will only do what you pass in here until it switches to the next state. So in here, self.state.update, and we're going to run the update. So this bit here, this logic, will swap the state depending on what we put in enter state. So this will return the new states. Then the update logic of the state is called here. So that will constantly happening for each state. So I hope this all makes sense. It took me a while to wrap my head around this when I was learning it. In here we need to pass dt and self. By way of doing that, when we call it in here, update self dt character, that is this. So it's going to do all this when you call character in here for the relevant character. So we want to put that animate in here as well, and we want to run the movement, so we still want movement. So this isn't self anymore, is it? It's this character, so the character physics. Character animate. And then this is idle state. And in here, we want the character dot get direction. All we need for that. I think we're also passing in dt. This is the speed, so 15 times per second. That should do the trick. And we want the character movement as well. Function. So when it's called on a player, it's going to move the player around. So we'll leave that blank for now. So it should just do all this, but stay in the idle state and just animate as idle, but it will still move around given that we've put these in. So let's see if this works. Yeah. So we're in the idle state. And then move to our little debugger here. Self.player.state variable. And print that on the screen. Just return idle, characters.idle. That's the object and it's in memory. So there we go. So that's working lovely. We've abstracted that into a state machine. Now let's add the run state and show you how that can easily transition. So in here, we need some logic and a condition of when it's going to move to the run state. So obviously the world's your oyster here. You can put what you want into this state and how it transitions to the next one. Obviously there does end up being more code, but it's a lot tidier and it's a lot easier to manage and it's a lot more versatile than lots and lots of if statements that I was using before I figured this out. So in here, remember we're using the character now, not self, because we're passing it in through here. Magnitude, that's how far away from zero it is. So that's how to ignore whether it's minus or positive. If it's -5, it will still return 5 because it's 5 away from 0, if that makes sense. So if the magnitude, whether it's minus or not, is more than 1, then return the run class, which is this. And literally, that's all we need to do. Let's copy it all down into the run class so we can see it transition. We still need all this. Remember, we want run here because in the run class we want the run animation, and we just need a similar logic here because when it's less than 1, we want it to flip back to idle class, return idle. So let's run that and see what. So here's the idle object. If I start moving now, when it goes, there we go. If it goes above 1, we're running. If I take off the keys now, and we're idling. Run, idle. Seamless transition. And you can do that for dashing, for attacking. Okay. Let's build on this a bit. Let's put an NPC into our scene and show you how versatile this is. So let's go into our scene. I want another layer here. I'm going to call it entities. I need to put that in my tiled software. So I've got that open here. And if you remember, we had all our layers up here. It's going to be an object layer. It's going to be called entities. And then I'm going to just put an NPC here. I'm going to give it a name over here called NPC. And then save all. Minimize that. So now I should have another layer I can call in much the same way as my entries. Here. I just need to go if entities now, because that's the name of the layer. In layers. This here imports all the layers from the TMX file. So entities will now be in it. And it's going to get to here and it's going to go, yes, entities is in layers. So I'm going to do this. Get layer by name entities. And if the object name is just NPC, because that's what we called it in tiled. And I'm going to just give this a variable name called NPC. And I'm just going to make an instance of an NPC. And I think that is the name. So that's what calls the relevant animations. So let's call that NPC. Go into here. And for now, we'll just copy this. And we'll call that NPC. Because it's going to pass the name in for the animations. So we need this here. For now, it's exactly the same as the player because I've just copied it, but you can have totally different images in here, of course. So that's NPC. And then all these parameters are the same otherwise. Where we're going to put, so it's already there. That's going to be the position where we put that NPC in tiled. Is that all we need? So name NPC is not defined. It's usually, which I always forget, up here from characters import player. We didn't import the NPC as well. Just separate all these by commas. And there we go, there's the NPC. So the NPC's movement method was just a variable which I can set to true or false, left, right, up or down. Where the player sets it to true, or false, left, right, up or down, depending on the key presses. So if I press down now, there we go, the player moves, but the NPC doesn't. And of course, the NPC is still using the state machine. Here, We give it a variable. So when it creates this scene, the scene has got this NPC. We can output the state of the NPC and idle, because there we go. It's telling you the state of the NPC, not the player now. So I hope all that makes sense. And with that, let's try and do a dash mechanic while we're here, just to show you the flexibility of this. So let's create another class, dash. I want to instance some variables in this one. So, here, I'm going to run a timer. Self.timer is 10. Let's say 3. And then in the update function, this is great with states. You can just put timers for when the state finishes as well. So self.timer minus equal dt should reduce by a second, 3 seconds. And then when the enter state is here, self.timer is less than 0, we can return idle. So I don't want physics, I don't want movement. So in the dash state, I don't want any inputs to affect the character. We want animate. Dash. Have I got dash in here? In the player. I've got no run idle. No, I've only got attack. So let's just call it attack for now. We'll do an attack animation. Do I want the physics? Not for now. Let's just put the character velocity is 0. Or vector of 0, 0. So let's go back here, put that back to the player. So when does it dash? So if I'm running or idling, I want it to dash. So again, inputs space. What inputs have I got to play with here? Let's use a right click. If you look at the past videos, you'll see all how we've been using this, and you'll know what all these are. So if inputs click, turn, dash, which is this. And we want that also to happen if we're running in the run state. So as you can see, the code does build up, but it's super, super tidy and super easy to debug things. It's a lot less error prone and mainly very scalable. So let's run that, see what happens. If I right click, okay. So it's trying to go into dash, but it immediately goes into. I think I'm not understanding this DT here properly. Straight away it's going by 30. Is it because I need to return this as false? No, it's not. So I know why it is, because we've got this here. We don't want it to return idle when the magnitude is less than 1. So as soon as we go into that dash state from idle, it's less than 1. So it's returning idle immediately. I think that's what's happening. So once it's gone into the dash state, the only way out of it is when this time has gone down, we go to idle, and it should stay still because in the update we've not got any physics going on. We've just got vector of 0, 0, the velocity. So there we go. And that's working for 3 seconds. So I was correct with my DT calculation. So if I right click now, no matter what I'm clicking or pressing, it's just going to run that attack animation, remember we give it, until it finishes. Nothing, 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 and then it moves. And it's proof here. You've got the dash object. And yeah, and you can just make your own states. So for example, if you want an attack state, you can actually put the sword slash or whatever it is you're attacking with on the animation of the player. And then within that state, you could generate a hitbox for the relevant side the player is facing, and then do a collision method with enemies. I'm hoping to do a tutorial on that later, where we'll do the sword slashes and enemies, so we can get all the basics in place, so you can make a game. And so we're going to go the next episode. I'm going to show you how to do room transitions, so you can build an open world, and eventually we can tie this to a map as well. So as you go into each room or area, it will populate a new section of the map as well. So just like a bit like Metroidvania, really, although we're doing an RPG. But I've already coded this before, so it's worth letting all you guys know how it's done and sharing the knowledge. I hope you've enjoyed it. I hope this has helped, and I'll see you on the next one. Thanks all again.